You know that feeling when you just, you blink and suddenly there's a brand new framework out there?
Oh, yeah, like every single week.
Right. A shiny new programming language or some, I don't know, absolute must-have tool dropping into the tech ecosystem. You open your feed, and it honestly feels like there are 5,000 new things you're supposedly falling behind on if you don't learn them literally today.
It's exhausting. It really
It
is.
creates this very real, very heavy sense of tech fatigue. I mean, how on earth are you supposed to master a craft when the ground you're standing on is just endlessly shifting underneath you?
Well, you drown, honestly. If you try to catch every single wave in this industry, you just end up drowning.
Yeah.
The counterintuitive secret, and this is based on the notes we have today from a veteran CTO and hands-on architect, he's got over 25 years of survival in this field, right?
Right.
His secret is that the best way to beat tech fatigue is to actively ignore, like, 99% of it.
Wow. Okay, well, welcome to the English Boost podcast. Our mission for this session is to deconstruct that exact journey, how you move from an overwhelmed junior developer to a true master architect.
Exactly.
Because what this veteran's experiences reveal is that true mastery isn't about frantically trying to memorize the entire internet.
No, not at all.
It's about letting reality force your hand. It's about learning the exact right things at the exact right time and demanding an environment that actually lets you do it.
And to start, I think we have to talk about how you anchor your focus. Because the antidote to that anxiety of missing out is letting professional requirements, not just your personal curiosity, dictate your curriculum.
Meaning you learn what the problem in front of you actually demands you learn.
Exactly.
I hear that, but there is this pervasive fear, that if we don't study up on the fringes, we just become obsolete.
I get it. But think about the massive integration platform this architect had to build. The notes describe this system that had to connect over 40 different backends.
40? That's insane.
Right. And when you're faced with a sprawling, monstrous reality like that, you are automatically forced to learn the heavy-hitting tools.
Right, you don't have a choice.
Exactly. You have to learn Kubernetes just to manage the sheer volume of containers. You have to understand circuit breakers. You have to build in idempotency and observability. The project demands it, so the learning actually sticks.
Okay, pause for a second because we definitely have listeners across the entire spectrum of tech. If someone doesn't deal with back-end architecture daily, what do those terms actually mean in practice?
Oh, sure. Fair point. Let's take the circuit breaker. It is exactly like the electrical panel in your house.
Okay.
If you plug in way too many space heaters, the breaker trips to prevent your house from catching on fire.
Yeah, thankfully.
In software, if one of those 40 external backends is struggling and just, slowing down, your software trips a virtual circuit breaker. It cuts off the connection so that the broken external system doesn't drag your entire platform down with it.
Ah, I see. And idempotency.
Idempotency is essentially the double-click safeguard.
The double-click safeguard.
Yeah. Imagine a user clicking a Pay Now button on a laggy website. They get impatient, they click it 3 times in a row.
Oh, I've done that.
We all have. Well, an idempotent system recognizes that all 3 clicks are actually part of the same original request, and it only charges their credit card once.
Got it. So when you're building a system that connects to 40 different databases and services, you just have to learn how to keep the house from burning down and how to not charge someone 3 times. You learn them because the reality of the work is forcing you to.
Precisely. If you try to learn circuit breakers in a vacuum.
Like just on a Tuesday evening.
Right. Just by reading a tutorial without a real-world problem to attach it to, that knowledge evaporates. In our source notes, the architect actually mentions a colleague inviting him to a seminar on quantum computing. And, I mean, it's a fascinating topic. But unless you are professionally engineering a quantum system that week, spending hours diving into it is just a massive distraction from mastering the actual code in front of you.
So it's kind of like trying to memorize the entire French dictionary before your flight versus just learning the phrase to order a coffee when you're actually standing in a Parisian cafe.
Yes, that is a much better way to frame it. The cafe forces you to learn the phrase. Now, the counter-argument people always raise here is about legacy code.
Right, because what if the project you're on uses outdated, boring tech? I mean, if reality dictates my curriculum, and my reality is a 10-year-old legacy system holding the company together with, like, digital duct tape, aren't I just stagnating?
No, because mastery is also about finding comfort in being uncomfortable. Even terrible legacy systems have deep architectural lessons embedded in them.
Really? Like what?
They teach you the long-term consequences of bad engineering choices. You see firsthand what happens when things are built poorly. Mastery isn't just knowing the syntax of the newest tool. It is that first-time right feeling.
First time right.
Yeah, it's understanding any system so deeply, knowing its bottlenecks, its memory leaks, its weird quirks, that you aren't just hacking things together until they magically compile.
You're making deliberate choices based on the scars of the past, essentially.
Exactly. Which brings us to a massive pitfall for people early in their careers. If building this deep understanding of systems is so crucial, you have to look at how the modern job market often forces junior developers into the exact opposite approach.
Oh, you're talking about the mythical full stack junior developer.
Go your Jess.
I see these job postings all day long. It's always startups with two people looking for a junior dev who can, design the front end, build the back end, manage the cloud infrastructure, and somehow also optimize the database.
It is a complete trap,
Yeah.
and it's setting those developers up to fail.
Why is that?
Because when you're forced to touch the front-end, back-end, ops, and cloud all at once in your very first year, you learn broadly, sure, but you never go deep. You never understand the underlying mechanics of how a computer actually processes your commands.
But look at the reality of the industry right now. If I'm a young developer and I decide to just put my head down and focus exclusively on mastering, say, back-end Java, won't these fast-paced startups just throw my resume in the trash? It feels like you have to be a unicorn just to get an interview these days.
I mean, they might hire the unicorn, but that unicorn will hit a massive ceiling in their career very quickly.
Interesting.
Our source material outlines the concept of the T-shaped developer.
Yeah.
Yes, you ultimately want the broad, horizontal top of the T where you understand a bit of everything,
Yeah.
but you absolutely must build the deep vertical stem first.
So how do you actually build that stem without just, reading dry textbooks?
Well, the architect heavily advocates for reading high-quality open-source code.
Oh.
And not just any random code on GitHub, but established, battle-tested frameworks. He specifically mentions reading the source code for the Spring framework, which is the backbone for millions of enterprise Java applications.
Wait, reading code instead of writing it? I feel like most developers just want to jump in and build their own stuff.
They do, but think about how a musician learns. You don't just pick up a guitar and start composing symphonies on day one.
Right, you'd be terrible.
Exactly. You listen to the greats. You study their chord progressions. When you read code written by highly experienced engineers, you start to internalize expert patterns. You see how they decouple their architecture.
Decouple meaning?
Meaning they write pieces of software that can be updated or swapped out without completely breaking the rest of the application.
Ah, okay. So it changes your mental model of what good actually looks like.
Yes, it gives you that foundational stem of the T. If you have a deep understanding of core principles like how memory is allocated, how to structure logic cleanly, how to decouple systems picking up React, or some new AWS service a few years later becomes trivial.
Because the concepts map over.
Perfectly. The mental models just map over.
Yeah.
But if you only have the shallow breadth, every single time a new tool comes out, it is this desperate struggle to learn it from scratch.
Okay, I follow you. Get the depth first. Master one language, study the masters. But let's say you've done that. You have this incredibly deep technical foundation. You know exactly how a system should be built. Here is where the real world gets messy. Right.
Always does.
You have to work with other human beings.
Yes.
How do you take that technical mastery and actually convince people to listen to your ideas?
And this transition from purely technical skills to the messy art of human integration is where a lot of brilliant engineers just completely fail.
Oh, I bet.
In the notes, the architect shares a fantastic story about working as an internal consultant at a highly traditional Dutch financial institution.
Oh, boy. I can already picture the boardroom, heavy wood tables, people who've been there since the dot-com bubble.
Exactly that. He is walking into an environment where developers have 25 years of tenure.
Mm-hmm.
They are deeply entrenched in their specific legacy ways of doing things.
Right.
They have their routines, their preferred tools, and a very, very low tolerance for outsiders telling them they're doing it wrong.
Yeah, walking into that room and saying, hey, everyone, my architecture is better, let's rewrite everything, seems like a guaranteed way to get stonewalled.
They will block you instantly. The psychological defense mechanisms just kick in. Highly experienced engineers do not respond to being dictated to. The lesson he learned is that you cannot win with a whiteboard and a theoretical debate.
So how do you break through that kind of institutional armor?
You master persuasion through pragmatism. You explain your reasoning, sure, but you tie your technical decisions directly to the pain points they are already experiencing. And crucially, you build a working prototype fast.
Fast, okay.
You get working software out into their hands so they can actually see the benefits. Iterating on a rough working product builds trust infinitely faster than presenting a flawless theoretical architecture diagram.
It's the difference between trying to win a philosophical debate about aerodynamics in a meeting versus just, folding a paper airplane, throwing it across the room, and letting them watch it fly.
Exactly. Show, don't tell.
Yeah.
Because once they see the airplane fly, they start asking you how to fold the wings.
I love that. But wait, doesn't getting it out quickly contradict everything we just talked about regarding doing things properly? I mean, if true mastery is the first time right feeling, doesn't rushing out a prototype compromise that standard?
Well, context is the deciding factor here.
Okay.
If you are building a mission-critical system, like the core transaction ledger for that Dutch bank, yes, you go deep, you engineer it with absolute precision. But if you're building an internal tool to prove a concept or a feature that marketing is going to replace in 12 months anyway.
You don't need it to be perfect.
Right. You apply different principles. You need a solution for now. True mastery is knowing when to be a perfectionist and when to be a pragmatist.
And this need for pragmatism really sets up the reality of how software is actually built today, doesn't it? Because nobody's just sitting in a basement writing isolated code anymore. Everything connects to something else.
Yeah, we live in a cloud, SaaS, and AI ecosystem now. The days of building a monolithic app entirely in-house are just over. Almost all complex software engineering today is actually integration engineering.
Right.
You're constantly connecting your system to a dozen external systems, payment gateways, third-party authentication, external AI models.
Which completely shatters the traditional way management tries to run these projects, doesn't it? Because we still have project managers demanding strict deadlines and delivery dates.
It absolutely breaks the traditional model. The source highlights how classic Agile or Scrum rituals, specifically things like planning poker, are utterly useless in modern integration projects.
For those who haven't sat through one, planning poker is where the development team sits in a room and basically votes on how many hours or points a specific task will take to complete, right?
Yes, and it assumes you control all the variables.
Right.
But in an integration project, you don't control the timeline. You are entirely dependent on third parties. You might be ready to code, but you're waiting for an external vendor to generate API credentials for you.
Oh, that's the word.
Or you're waiting on documentation from a different team across the globe. Or a third-party testing environment is just down.
So you can't estimate how long a task will take when the blocker is a company you don't even work for.
Exactly. But this creates massive friction with leadership.
Well, yeah, I can imagine. If I am a stakeholder footing the bill for a massive corporate project and the engineering team tells me, hey, estimates are useless, we'll be done when we're done because we're waiting on a vendor, that sounds like an absolute nightmare. How do you justify abandoning deadlines to the people writing the checks?
It sounds like a nightmare to them because of a much deeper systemic problem in the industry, and that's the expertise drain in leadership.
Expertise drain.
Yeah. Across IT, government, healthcare, we are seeing managers who are exclusively taught generic process management. They know how to read a spreadsheet, they know how to track a burn-down chart, but they have zero hands-on understanding of the actual technical work being done.
Ah, so they manage the metrics on the dashboard, but they don't know how the engine works.
Exactly. And when a manager doesn't understand the engine, they force developers to put arbitrary estimates on tasks that are actually blocked by external factors. That doesn't create speed. It just creates waste.
Yeah.
It creates stressful status meetings where developers have to literally invent reasons for why the third-party vendor hasn't emailed them back yet.
So what is the alternative that actually works then?
Technical leadership must have hands-on experience. A true technical leader understands that the solution isn't stricter deadlines, it's flexible iterations. Working in, say, 3-week cycles where you demo whatever actually works. You drop the anxiety of the strict timeline. If a feature is blocked by a vendor, it's blocked. You pivot, you work on a different piece of the puzzle, and you maintain momentum without all the bureaucratic theater.
Okay, but let's talk about the risk of working like that. If we're dropping strict timelines, iterating fast, and pivoting constantly, the traditional corporate mindset will scream that we are introducing massive risk. Moving fast breaks things in production.
And this might be the most profound, counterintuitive insight from the entire source text.
Okay.
The traditional corporate mindset believes that to reduce risk, you must slow down. You accumulate changes for 6 months, you put the code through endless review committees, you get 50 sign-offs, and then you do one massive deployment over a weekend.
Because deploying code is viewed as inherently dangerous.
But the reality is the exact opposite. Deploying faster actually makes your system significantly more resilient.
Wait, really? How?
Think about the 6-month cycle.
Mhm.
If you wait half a year to deploy a massive chunk of code, nobody on the team even remembers the context of what they wrote back in January.
Oh, that's true. You're deploying code written by a past version of yourself that you don't even recognize anymore.
Exactly. And when it inevitably breaks production, finding the specific bug in that mountain of new code is a nightmare. Compare that to deploying daily or even weekly. The changes are tiny. The context is fresh in the developer's mind.
Makes sense.
The architect actually shares a great story about doing a final production deployment right before leaving for a holiday.
Deploying right before a vacation, that is a bold move. I would never do that.
It is. But he spotted an unexpected error right after it went live. Because the change was so small and the code was so fresh in his mind, he realized he'd introduced the bug himself. He wrote a fix, tested it, and had it deployed to production in 20 minutes. Tops.
Wow. 20 minutes to fix a production error. The traditional risk management mindset says, put up thicker walls, add more guardrails, test everything 50 times before it moves. You're saying that the best safety net isn't a thicker wall, it's just a really fast ambulance.
That's exactly it. A fast ambulance is infinitely better than a thick wall. When you have a thick wall, you eventually crash into it anyway, and then you don't know how to recover. The architect contrasts this agile approach with a regulatory audit he went through. The auditors literally forced the development team to take manual screenshots of a Docker registry.
Okay, for context, a Docker registry is basically the digital warehouse where all your ready-to-deploy software containers are stored, right?
Yes, and the auditors wanted manual pictures of it to prove what version of the software was running for compliance reasons.
Taking a picture of code with a screenshot tool, that sounds completely insane.
It is pure bureaucratic theater. It is overhead that makes stakeholders feel safe on paper, but it does absolutely nothing to actually increase the safety, visibility, or resilience of the system.
But to have that fast ambulance, to be able to fix something in 20 minutes before you catch a flight, you need immense visibility. You have to know the crash happened immediately.
Yes, which brings us to the ultimate litmus test for any software engineering environment. If you want to achieve mastery, you must have an unbroken feedback loop. The developer who writes the code must be allowed to see that code running in the wild.
Right.
They must have direct access to the production logs.
It seems obvious. I mean, you can't fix what you can't see.
You would be shocked. The architect uses this as a baseline question when interviewing candidates. He asks, were you able to see the production logs for the systems you build?
And what do they say?
So often, developers coming from large traditional enterprises say no. If there was an error in production, someone in the operations department would have to email me an export of a tiny piece of the log file.
Wait, they trust you to write the code that handles millions of dollars and runs the entire business, but they don't trust you to look at the text file that says how the code is performing.
It completely breaks the feedback loop. If you cannot see what your code is doing under real-world stress, you will never move beyond a certain level of competence. You will never reach true mastery because you are flying blind. You're just guessing.
Wow. Okay, we have covered some serious ground today on the English Boost podcast. Let's pull all these threads together for anyone listening who really wants to level up their career. The journey from a junior developer to a true master architect isn't about memorizing every new shiny framework that pops up on your feed.
Far from it. It's about letting real-world problems drive your learning. It's about building that deep, vertical stem of knowledge, first by reading great code and understanding core principles before you spread yourself too thin across the full stack.
It's about pragmatism, too. Knowing that folding the paper airplane and showing it flies is way more persuasive than a theoretical boardroom debate. And above all, it's about demanding an environment where you are actually trusted to see your code running in the wild so you can fix it fast when it breaks.
Exactly. Look closely at your current environment. Are you in a place that fosters this kind of deep growth? Or are you just hacking things together to meet an arbitrary deadline set by a manager who doesn't even understand the technology?
Right. If you are flying blind without access to your own production logs, it might seriously be time to start looking for a new runway.
And if I can leave everyone with one final lingering thought to mull over, it's about where this entire industry is heading next.
Okay, let's hear it.
As AI tools get better and better at writing the basic boilerplate syntax of code, the job title of software engineer is going to shift radically. It is going to shift almost entirely into becoming an integration engineer.
Meaning the actual typing of the code becomes the easy part.
Exactly. The most valuable skill in 10 years will not be writing the syntax yourself. The most valuable skill will be debugging the chaotic, unpredictable conversations happening between a dozen different AI models and your company's 20-year-old legacy system.
Oh, wow.
The AI might memorize the dictionary, but you have to keep the kitchen from catching on fire. Are you ready for that shift?
Man, that is something to seriously think about. Thank you so much for joining us for that. We'll be back with more mind-expanding insights next time. Keep building, keep learning, and we'll catch you then.